Welcome back to HANA Basics for Developers. Now we've talked extensively about the asynchronous non-blocking nature of Node.js. And we've seen how it impacts the programming model, in particular when we looked at database level access, the use of callbacks, promises, async, all these things to minimize the impact and control the flow more in a way that we as human beings think. But we've also seen how the efficiencies that Node.js gets by being able to do most everything as an evented process, so that it doesn't have to stop and wait on input or output. It can move on and process something else. During this time that normally most computer programs would just simply have to wait. But you've kind of had to take my word for it. I haven't really, I've shown you code samples, but haven't shown you how the execution flow is really impacted by this asynchronous non-blocking nature. And that's what I'd like to do now. What I've done is I've prepared a little demonstration user interface. And of course, with the web browser, we have the request response cycle. So even if something, even if two lines of code are executing in different orders, we generally don't get to see that in the web browser. We have to wait until everything's done, and then we send the response to the web browser, one response. But utilizing WebSockets, we're able to get real-time two-way communication between a web server and a web browser. So that's going to allow us to push output directly to the web browser as soon as a command is finished. Now, we're going to utilize WebSockets in this exercise. I'm not going to teach you a whole lot about WebSockets. We have an exercise later that will do that. But for now, let's focus on learning about this asynchronous nature, and I'm just letting you know this is the little bit of magic that we're going to use. It's going to allow us to see the order that each of our commands are executing, because we'll be able to see them pop right into the web browser on the client side. So let's go back to our project, and what we want to do is we want to add another route to our RESTful service. So we'll come here to index.js, and we'll just add it right here, app use, and what are we going to name this route? We're going to name it Node.exe async, and we're going to take this and pass it to routes exercise async. Oops. And if you remember earlier, much earlier, we were passing the raw low-level server in, and I said that was so later we would have it to use once we need WebSockets. So we are going to pass that server into this route handler because it's going to need it, because it's going to be WebSockets based. Okay. Now what we want to do is create a new route handler for that. So come here to our routes folder, exercise async, and I've prepared the code for this in advance. So this is 5.7. And actually, I'm not going to go through all this code. This isn't really the interesting part of this. This is just setting up the WebSocket. Like I said, we'll come back later and learn more about WebSockets. It's enough to know right now just that we're going to utilize that technology to help us learn about the asynchronous nature of JavaScript. We don't need to go into a whole lot of details there just yet. Now, what I've done here is I've prepared a bunch of Node.js samples. So we're gonna type them all in. We're gonna download them here, and we'll bring them into our project. We'll look at the coding, but what we're gonna do is we're gonna look at them once we start executing them. So really, we're just trying to get our little test framework ready here, and then we will study the source code. But we'll do that in a minute once we're ready to really test it from the web browser. So what we want to do here is we want to go ahead and import this. Oh, I'm sorry. This is actually the This is actually the web page that the little website that I want to bring in. So we'll bring that into resources. All we have so far is our index HTML with our hello world. This is going to be our first real big SAP UI5 application that we're importing here. So exercise async, and put in resources. Yep, that looks good. Let's go ahead and bring that in. For the content. There we go. We're just bringing in some, some icons, the SAP icon, the favorite icon. Nothing too special going on there. A couple of reusable JavaScript libraries that we're going to need in this UI, and then the async, this little test framework that we're going to see here in a minute. Once again, I'm not going to go into a lot of the details of the structure of this UI. That isn't the purpose of this particular video. We'll learn more about SAP UI5 later, I promise. For now, we're just going to use it as an ends to our means here. The last thing we need to do is, because we're using WebSockets, is we actually need to come in and tell the app router that we're going to do that. So we should come here to the XS app JSON, and we're going to add a couple things here while we're in here. We're going to add a logout configuration as well. That's good to have so that we can configure when the user hits the logout button what we want to happen. So logout page, take that to logout.html, and then logout endpoint. Take that to my logout. There we are. And then we want to add web sockets and enabled true. Okay, that looks good. The main thing we need, because we're using WebSockets, they would be blocked automatically by the app router unless we turn them on. The app router, of course, supports WebSockets, but for security reasons, we have to basically say, yes, we want to use them, so that's what we're doing here. And the little app that I imported does do logout, so I needed to add that. So I'm just being precise here. I have a logout button in the page, and if I would click it, I would get a syntax error if I don't add this configuration. I don't like that, so we'll use that later in some of our SAP UI5 applications anyway. So let's go ahead and get that set up. Now, the last part, we have a couple of little sample Node.js examples that we want to bring in. We're going to put those in their own separate folder here that we're going to call async. I mean, the name doesn't mean anything, doesn't have an impact on anything. I wouldn't have to put this in a separate folder. I'm just doing that to keep my project neatly organized, to keep everything from this particular exercise together. And I've prepared all these together in one zip. So we'll bring that down and import it here. So import the async. Double check my path. Yep, that looks good. And it's brought in a bunch of examples. Like I said, we're not going to look at them just yet. Let's get our application running, and then we can do this side by side as we execute them. So let's restart the SRV module to pick up the new content. And once that's finished, then we have to restart the web module because we changed the configuration of the XS app JSON. So we'll give that a second to restart. There we are. It still goes to our hello world, but let's change this. Now we got another web app in here. Let's go to exercise async. There we go. And actually what I want to do here, let's do the side-by-side thing. I think this is this is a good way to study this. There we are. Let's put our test application on one side. Let's look at the source code on the other side. And we'll start here with async.js. And this is a really simple example. We're just going to output when we start our code, so line 5. Then we're going to start a little function that's going to set a timer and basically say wait 3 seconds, and at the end of 3 seconds broadcast this message, wait timer over, and then we have another line of code after it that says end. Now in a traditional programming environment, what would we expect the output to be? We would expect to see start, we'd wait 3 seconds, then we'd see wait timer over, and then we would see end. But what happens when we run this in Node.js? We see start, we see end, we wait our 3 seconds, and then we see wait time over. Because Node.js starts the process to wait 3 seconds, but it itself doesn't wait. It moves on to the next command, which is actually the end command. So as we've seen, hopefully this reinforces the idea that the order that you write your code in is not necessarily the order of execution. And that's a good thing from performance, but it means sometimes we need to account for that. You can imagine if this was 2 different database queries, and I wanted to take the result of the first query and pass it into the second query, I can't just assume that that first query is going to be done by the time that it reaches the second query. And that's why we have to do all this embedding and callback and promises and async and all the earlier stuff that we taught you. That's to control the flow when we want to override the asynchronous behavior. All right. So to further reinforce this, let's look at something like file processing. So Node.js actually has the ability to read files 2 ways. There is a synchronous file reader and writer, in which case it executes, I would imagine, largely like you would expect, that we issue the command that we are going to read the first file. Then we actually output the content of that first file. Then we have an after we've read it. Then we read the second file, and then we issue a command. So it executes exactly in the order that you would expect for a traditional programming environment. But let's look at the same thing using file async, and notice the APIs, read, file, sync. But the asynchronous one is just read file. It's assuming in the Node.js environment that you always want async. And it's actually synchronous that requires a special API to act differently than the norm. So I think that just the naming of the APIs there are pretty telling. But now let's do the same execution but using the asynchronous reader. And what we see here is actually both after commands come out first. So not only are we out of order, but it isn't even that the entire first file finishes before it moves to the end of the program. The act of opening a file at the operating system level takes relatively such a large amount of time compared to just issuing commands that even speaking on a WebSocket, that we're getting all of our after statements before even a single file has been read. The other thing we see here is, look which one finished first. This is my second file. So it's actually the file that we opened second that finished first. And particularly that could happen if these files were significantly different in size. Say file 1 was really large, of course it would finish after file 2. But just looking at the code, you wouldn't necessarily know that. Nor is it consistent. Let's run this again. And pay attention here. Second file is before first file. I ran it again. I got lucky on the very next attempt. Now first file finished before second file. There's all kinds of factors at play here that can impact the performance, and we're not beholden to the order in any way. So one time you execute your code, one file is going to finish before the other, and the next time the second file is going to finish before the first. You have no way to reliably know which file is going to finish first. And of course, if you don't have any dependencies between the two, and if you're streaming the data to the client side, it doesn't matter. The data is going to get there when it gets there. But you can imagine in many scenarios we do have dependencies. We do need sync points to know when to we have a consistent result, and to be able to communicate that to the end user. We can't always just stream it to them as it happens. All right, let's look at another example. So we've seen a timer. That's a pretty obvious example. We've seen reading a file from the file system. That's another type of I/O. Another very common type of I/O is making an HTTP request. So here we are. We're going to call, if you remember back to our XSJS outbound video, we called the Library of Congress and did an image search. We're going to do the same thing here from Node.js, and you're going to see how it's also asynchronous. There's no reason to wait on the response from that external web server. We can go on with our processing, and then when we get the results, we'll handle those. In this case, output them in the WebSocket as well. So what you see here is I get my before, I get my after. So any code that's executing after this command could be executing before we actually get our response. Now we've kicked off the request, we've made the request, but we don't get the results back till, like a fraction of a second after we've actually moved on from this to the next line of code. So once again, you can imagine if we had multiple HTTP requests, it'd be very efficient. They would be handled in parallel. But if there's dependencies between them, we have to think about that. We don't know what order they're going to execute in, just like the two file reads. We didn't know what order they were going to execute in. And the final example that I want to look at, this one's an obvious one since we're in the HANA environment here, is database level access. So naturally, database queries, as we've seen, we might want to do them in parallel. And of course, that's what this example is going to do. We're going to issue two database queries. We're going to issue a command before and after. And guess what's going to happen? The after command comes out before any of the database queries are done. We're going to make, we even see that inside the database query, different things are happening at different times. Each of these is making a connection to the database, but actually the second query finished the connection to the database before the first query did. And that's probably because the first query had to establish the connection pool, and the second one was able to just grab an entry out of that pool. And then we actually see database query 2 coming back before database query 1 is done. And here we see the database query 1 results. So once again, we don't know the order that things are going to happen in. We don't know which one's going to finish first. I'm sure if I did this again, notice here, query 2 is the one that comes back first. Query 2, there. It took me 2 times, but eventually I got one where database query 1 came back first. So we have to throw away all of our assumptions is basically, I hope, is what I'm impressing upon you most. We as developers make a lot of assumptions about the order of execution, the flow, the dependencies, that simply because I put the second query after the first query that it's going to execute dependently upon the first. But that simply isn't the case now with Node.js. And to that regard, you can imagine here, if I don't know which one's going to finish first, and actually my code after the database calls, so this code here after executed before the database queries were done, what if I want to push the results in a normal response object? Well, if I just had my response output here as this 10th line of code, it would be empty all the time because the queries aren't done yet. So we also have to have the idea of sync points. We have to have some logic that allows us to say, do all these commands, and only after they're all done do we finally send the results back. And in this case, I'm going to simulate that in this final example. I'm going to output the database query 1 and database query 2, and I'm going to have one final command. Everything's really done now, go home. That should always be at the end, no matter what order things execute in. So what we see here is before, we see the after coming as the next thing that's being output. Then we're getting our connection to the database 1 and 2. Database query 2 actually finishes first. And that's funny because it actually has more data being returned than database query 1, but it just so happens it comes back first. And we're talking about in this case, milliseconds different, because these are both very small queries. They aren't taking very long to execute. But you can imagine if they were larger queries, more data, this could have a significant impact on the performance of your application. If it took 30 seconds to execute query 1 and 20 seconds to execute query 2, instead of 50 seconds total, it should only take like 30 seconds, the time of the longest query to come back. But as we would expect, the everything's done, now go home is always the last command that comes back. So if you need the results of both these queries to perhaps do a third query, to do some calculation, if you need to know when you are consistently complete and you have all your data retrieved, there's mechanisms. I'm using the async parallel command here. We talked about this in an earlier exercise that gives us our consistent ending. And as many times as I run this, sometimes 2 comes back there, sometimes 1 comes back first, but it doesn't matter. We're always going to end with the everything's done, now go home. Okay? So, we didn't go into a lot of the technology here. I'm using WebSockets and SAP UI5. Don't be thrown off by any of that. It was just a tool that I hope helped you better visualize what it means to say that Node.js uses asynchronous non-blocking, help you better plan for the execution flow in this environment, and better realize why we needed some of that special syntax and modules earlier, and the whole concept of callbacks maybe seemed overly complicated at first, but hopefully this exercise has helped you see exactly why that's so valuable, and necessary, and help you better plan for coding in this Node.js environment.